Alright, so today we're going to look at we're going to add two more things to our function families. We're going to add in logarithmic and exponential. So our first one is logarithmic. Logarithmic functions lay down. So as you go across, they're just laying down. Okay, exponential functions are going to slope up. You can see we have natural log, or we have log. That log, we have the base right here. So for us, we're going to see them as ln. I always write mine as script. ln of x, or we might also see it as log, probably just base 10 of x. You could have any base, but we're going to look at base 10 for the most part. Alright, next is exponential. So exponentials sweep up. Okay, logs lay down, exponentials sweep up. They're inverse functions of each other. They reflect across the line y equals x. Everyone here, we have a base, and we have a power. Here's my power. You can have something occurring on the outside with this shift up and down. Okay, so all of the functions will be a base to some power. So it's a base number to a power. So you might see it as a to the x. So a is your number, x is your power. X-intercepts are also going to be a little different. So for a logarithmic function, again, logs lay down, we do have an x-intercept here. It appears to be at -1, 0. For exponential functions sweep. They can sweep up or they can sweep down. This one's sweeping up. I don't have an x-intercept. You can write none, or you can write D and E. D and E stands for does not exist, because in this case it doesn't exist. And as always, our zeros are the x values of the x-intercepts. We can also see solutions or roots. That could be something else that we call zeros. We look at our y-intercept. Again, our logs lay down. This is my log. I do have a y-intercept. Let's call that. It doesn't quite look like it's at 1. Let's go 0, a half. Our exponential function, sweeping up, also has a y-intercept in this case, and that's 0, 2. So what happens when the curves get flat? Well, when the curves get flat, we have what are called asymptotes. Okay? An asymptote is a line. When graphing a function, it gets closer to the value, but doesn't actually touch the value. Okay? We usually will see them as dotted lines. Give me something like this. It'll get really close to this, but won't actually touch that number. Okay? Logarithmic functions always have a vertical asymptote. I don't know why I wrote mine this way. Always have a vertical asymptote like this. And exponential will always have a horizontal asymptote. It gets very close to that value, but it never actually touches that value. When we write an asymptote, we're actually going to write the equation of the line that it's approaching, but it never actually gets to. In the case of this logarithmic function, we have our asymptotes right here. It's on the y-axis, and that means that I'm going to have x equals 0. So x is 0 in this case. For my other one, for my exponential function in red over here, okay, this is my asymptote. So it's actually approaching the x-axis. That's when y is equal to 0. So they're both going to be numbers. That's the value of, or that's the equation of those lines. All right, domain, let's keep in mind that that's our x values. So when we're doing domain, you want to find your asymptote. Okay, in this case, I'll do it in orange. Our asymptote's right here, it appears to be. Okay, see if the graph is going left or right. Use appropriate symbols that would be less than or greater than. Now, because you approach your asymptote, but you don't actually hit it, it's not equal to that value. Okay, so we cannot use less than and equal to or greater than and equal to. In this case, x is to the right, so it's greater than 1. In the example on the right-hand side, that's in red, and I'll highlight it, or I'll go over it in blue. Just kidding. Here we go in blue. It's exponential. This has a negative exponent. Okay? And this is always going to be all real numbers is your domain. Because I can put anything I want into my function. We can denote all real numbers by E. It can be all real numbers, that R with a line in it. Alright, domain are my X values, range are my Y values. Okay? Range of a logarithmic function are all real numbers. It can be anything, all the way from negative infinity can come out of a function to positive infinity. Okay, so again, Y is all real numbers. For your exponential function, I'll highlight again in blue. So for our blue over here, first we have to find out our asymptote. So I guess down here, and -2. And then we're going to determine, is it going up or down? So if it's going up, we're going to use less than. If it's going down, we can use greater than. And then what we're going to say is, we still can't use equal to. Remember, we approach an asymptote, we don't actually go there. So in this case, I'm greater than, Y must be greater than -2. I apologize when I said up. So up is going to be greater than. I misspoke before. And down will be less than. Alright, let's try a practice question. So now we have four functions in our function family: linear, quadratic, exponential, and logarithmic. In this case, we have exponential, it's sweeping up. The x-intercept, well, we have to see. What does it touch? Does it ever touch the x-axis? And the answer there is no. So I'm going to put D and E. Because the x-intercept does not exist. The y-intercept is touching the y-axis when y is 5 and x is 0, so 0, 5 is my y-intercept. Is there an asymptote? Yes, we're approaching the x-axis and don't make it there. And the equation for that would be y equals 0. So my domain, because it's exponential, is all real numbers. My range is going to be all the values of y. Y must be greater than 0. Keep in mind, you can also just write all real numbers if you want to. Okay, our next function here is logarithmic. So logs lay down. You can see it wants to lay down. So here's our logarithmic function. I do have an x-intercept. Yeah, it looks like it's really close to 1. It's a little bit bigger than 1, 1.0, I don't know what it is. But because, and I'm saying that, because if I have an asymptote at 1, it can't be equal to 1. So there's kind of that part there, unless you want to claim your asymptote's a little less than 1. We already talked about asymptote being x equals 1. Our y-intercept, we don't have one, so D and E for that. Bless you. So our domain is going to be every x value. In this case, I have to be greater than, I have to be larger than 1. And my range are going to be all real numbers. And again, you can write all real numbers. Or you can write y all real numbers, such as all real numbers. Okay, let's look at our next one. This one's actually a linear function. Remember, linear has the word line in it. It's a linear function. Go back to blue. You have an x-intercept. I seem to be just under 1. Maybe we're going to call it -0.95. Who knows? But there's my x-intercept. My y-intercept is at 1. Do I have an asymptote? No. No, I don't. Domain. So it's really important to know that x is going to be all real numbers here, and y is also all real numbers. Remember, unless you have a vertical or a horizontal line, unless we have x equals the number or y equals the number, it's always going to be all real numbers for both domain and range. Alright, let's hop to the last one. You can do the other two in there for practice. So this last one is quadratic. A quadratic looks like a U or an N. My x-intercept here is actually at the origin. My y-intercept is also at the origin. It's the only point where both the x and y meet. Is there an asymptote? No, there's no asymptote. The asymptote does not exist. Because I'm a quadratic function, I can say x is all real numbers. But my y is going to be less than 0. Less than or equal to 0.